Uh, okay, hi. I'm not sure if anyone needs English version, but I tried to prepare this talk in Polish, but the unavoidable mixture of Polish and English was so painful to my ears, so I decided not to inflict it on yours. Not sure how the microphone is working. Is it okay? Yep. Okay, so my name is Marcin, and I'm gonna talk about site reliability engineering and about some basics of it, because honestly, I'm at the beginning of this career path myself. So I started in January this year, after spending like over 3 years in the project. So some colleagues asked me, asked me to join them in the SRE team. So I didn't know exactly what it was about, but I needed some change. So I said, okay. So before diving into site reliability engineering, a bit of a background where the need for SRE originally arose from. So if we think how software has been traditionally made and deployed, it's like there are two parts, two different sides. There is the development team, who writes the code, maybe hopefully tests it, maybe writes some documentation. What the developers like is to play with new things, change things. So development is all about changing stuff. And in many organizations up to this day, when developers are done with the code, tested and prepared the releasable artifacts, they just throw everything over the fence to the operations team. Well, operations team is not too keen on change. So change is kind of an enemy to the operations, because most of the problems that happen in production environments can be tracked down to some kind of change, be it a new code release or configuration change, changing traffic patterns. So what the operations teams are incentivized to keep everything running and running stable. So any kind of change is not really welcome. So the two sides have like conflicting goals. So there is this gap between them, and this conflict really creates suboptimal ways of creating and deploying software into production. So people at Google in like 2003, so 16 years ago, so quite a long time ago, have decided to try something else. So they created a team of 7 people, software engineers, and they called it a production team. And the team was tasked with designing operations, designing how to run operations in a different way. So they got software engineers and told them to think how they want to run their software in production. So well, they are still doing it, and they are still they are training a lot of SRE every month, year. So it probably kind of worked for them. So the things that changed is that well, the SRE team compared to the operations teams, like traditional operations teams, is not about just supporting, just making sure everything runs stable. It's about engineering, because if you tell software developers to do this production stuff, well, they will get bored with the repetitive manual task quickly, so they will start automating things. Well, that's a good thing, and that's something we want in SRE teams to happen. So this gives us benefits. This improves the scaling of our systems, or yeah, it gives us an opportunity to have sublinear scaling of the operations team as the service scales up. Uh, and yeah, and ideally, if people running those production systems are engineers and want to automate things, so hopefully at some point those systems can not only become automatic, but also not only automated, but also automatic. So they will be self-healing and will require very little human interaction. So other things that change is that SRE is not about just reacting to problems happening, is about proactively looking for problems that before they happen in production. So fixing bugs before they hit the business. And also, it's unlike the traditional operations, it's not about preserving the status quo, it's not about keeping things as they were, it's about pursuing change. And so this closes or makes the gap between the two sides narrow, and I'll talk about that later on. So the thing is that SREs are software developers, so they can not only work change the infrastructure around the applications, but also the application code itself. So it's a bit different than the traditional approach. And the bonus is that they have pretty much the same skills as developers in the development team. So you can put an SRE back to the development team, or you can get a developer out of the development team into an SRE team for like training, so that they become more aware of what running a production system involves. So. Yeah, that was this. Okay, so the reliability is, if we think about it, it's kind of a fuzzy concept, because depending on the kind of system you work on, it will mean different things. If you create a database or data storage solution, maybe data durability is an important concept for you. If you work on online transactions processing, that will be latency and the availability of your service. If you have a batch processing system, it might be the important thing might be the end-to-end latency. So this reliability means different things depending on your context. So if SREs are supposed to maintain the reliability of the systems and improve it, so they need some kind of measurements that they will show whether they are doing a good job or not. So there's a thing called service level indicators. So those are the things that we identified as important things for our business, and the SR team should be able to provide some way of measuring those. So it's not only a technical concept, but it's strictly related to the business, because it might not be only about things like latency, availability, durability, or error rate. It can also be more business-centric metrics. So those numbers, we will probably aggregate them somehow, look at what the distribution is over time. Here, we can fall into some traps related to statistics. So, like, averages are not really great for measuring things. Neither are large time windows. So, those measurements will show us the current. This SLIs will show us the current state of the system, and when we define those, we only set up some target values for those measurements. So those are SLOs, or service level objectives. They highlight the things that are important for the business. things that users care about, because honestly, if you've got like 9 nines of availability, it's not important if your users are still not happy. So it's those are not only like technical things, and also SLOs help to set expectations regarding the level of service of your software, and this is kind of important to have the SLOs advertised to the consumers of your to the users of your service, because otherwise they will make assumptions how reliable your service is or isn't. And of course, it might be a good idea to keep some safety margin. So maybe have two kinds of SLOs for our internal purposes and for the external users, so that we have some safe space. And obviously, it's not trivial to define to find the right values for the SLOs. But we don't have to nail them on day one. We can adjust them as we go, seeing how our services behave. So SLOs are usually defined in a way like 99% of our requests should finish in like under 50 milliseconds. So there's this we should allow for some violations of those target numbers, because 100% SLOs are not really realistic, and we don't really want them. It might seem a good idea to say, well, our service is 100% reliable, but that only means that we are not ever changing anything, because change will inevitably bring problems, and we are not in control of everything. There are things like networks that we cannot control, so it's not realistic to think that we can achieve those goals. Also, the closer you get to 100% on your SLOs, the more expensive it becomes to improve your metrics. So it's also something we need to remember. It doesn't come for free, like high reliability. And as I said, if you want 100%, you give up any kind of change. So you kill your ability to innovate completely. So we want to be reliable enough, but not more than that. And what SLOs lower than 100% give us is this space to break things. So this is something we call an error budget. So it's 100% minus whatever you have got in your SLO, and we can, as we release new versions of the software, we can watch the remaining error budget, watch how quickly we consume it, and make some decisions based on it. Maybe if we are using too much of our error budget, maybe we should slow down, do more testing on our releases. Yeah, so this error budget should be visible for everyone. So for developers and the series and business, so it can serve as a natural balancing mechanism for innovation versus stability of things. So it reduces having it explicitly visible for everyone, reduces the amount of like political infighting, and reduces the friction between development teams who want to do change and SREs who want to maintain the stability of the system to some level. So when we see our current consumption of the error budget, we can make decisions about amount of testing, about how carefully we are proceeding in production with the new versions, with any kind of change. Okay, so those are ways for us to see how reliable or unreliable we are. And now I'd like to talk about some fundamental ideas of SRE and things that we're doing in the daily work. So first, as I said before, SRE is not about support. It's, I would say, mostly about engineering. So it has a strong focus on engineering. So SREs are software developers, so they've got coding skills and they can write code. They can change the infrastructure code, the scripts, automate things. They can also change the application code. Of course, there are some things that we don't have automated yet or are expensive to automate, and it's hard to justify such investment. There are things that are still like manual work, repetitive, and we call those things the toil. So yeah, if something we do is manual, repetitive, automatable, tactical, doesn't create a lasting value and scales linearly as the service grows, so we need to, if the service grows I don't know, twice the amount of users, we need twice as much work to be done on it. Well, this is probably toil. It doesn't have to have all those qualities, but one or two is enough. So things that are manual, it's like things we do manually. It's also running a script that automates those things. Well, so running this script, finding it and running it, it will be still toil. Repetitive doesn't mean things we need to do twice, but things that we do over and over again, like releases. This, if we do it like manually, it is toil. Things that are automatable means things that can be replaced by some kind of software, things that don't need to make human judgment. If they need human judgment, it's probably not something we can easily automate. Tactical, so it means reactive and here and now, and not about thinking long term. And yeah, the lack of persistent value means that the state of things is pretty much the same after we've done it as before. Well, yeah, we might have put out a fire in the production, but still it can happen again. So it's it is not engineering work, really. So things that are considered toil are incident reactions. So when you've got some alerting going off, as I said, releases, answering some non-urgent questions or issues with the production. It's yeah, there's a lot of such those things in the daily work, and if we've got too much of it, it gets dangerous. It might have bad effects on people. So like people will get bored because, well, yeah, it's not repeatable work is not something software developers like to do. It will make people unhappy, maybe lead to burnout. If you hire an SRE and then they only have toil to do, they will be like disappointed and feel cheated. It's not the position you told us it would be. So what we should be striving for is limiting the toil and limiting it aggressively. Like Google caps toil at 50%, over some period of time. It isn't 50% daily. It might be over a quarter or 2 quarters. So you can have periods of time when you do a lot of toil and periods of time when you strictly focus on engineering. And it might not be easy to limit this kind of work because someone needs to do it. So there are one thing to remember is that you shouldn't just grin and bear it and keep quiet about it. You should be telling someone out loud. If you have an SRE team, you probably have some level of management buy-in for this idea. So yeah, you need to talk to your managers. Maybe you need to grow your SRE team to just spread the load on multiple people. If you cannot, maybe it's time to push some responsibility for the production environment back into hands of development team, because they shouldn't forget about the systems they've created. And then the focus on engineering that SREs should have is also reducing the toil in the longer run. So the things that SRE do that lead to permanent improvements, that really need some human ideas and that are innovative and like long-term thinking, those are all engineering. And one thing is that it reduces the toil. So if we automate things, we will have less manual work to do. But it's also about improving performance and stability of our systems, resource utilization, which in turn could lead to reduced amount of toil work, which is a good thing, but it's not the only goal. So in our project, we, for example, had the SRE team lead an effort to remove some performance bottlenecks that we had for a long time. So there was 2 SREs and a bunch of developers from the development team who finally fixed those things, and it really made the life of the on-call engineers a lot easier, a lot better. So, and the engineering part is also about reducing the amount of work we need to do to keep our systems running. So this is the sublinear scaling part of things. So it leads to a more efficient setup than just having a development team that hands over the binaries to the operations. So the engineering work SREs do are of 2 kinds. First is software engineering, which is about writing code, changing code, or maybe writing documentation, testing things, designing things. But it's not the same kind of software engineering that the development team does. It's about the focus is different here. It's about automating things. It's about creating some tooling or frameworks. It's about adding some features for improved scalability and performance and reliability, and about creating a robust infrastructure for developers to use. And the other kind of engineering work is systems engineering. So it's all about configuring production services like load balancers, OS parameters, JVM parameters. It's about creating valuable documentation that will help people, like maybe run books for on-call engineers. It's about setting up and maintaining, updating the monitoring for the system, because we need some way of seeing how things work. And about working with the development team so that they become more aware of what works and what doesn't work in production, because it's not always obvious. So that was about the focus on engineering. The next thing, as I said, SRE is not about support, is not about maintaining status quo. SRE is actually about going with our changes as quickly as possible. And by as possible, I mean without violating our SLOs, without violating them too much, because we still have the error budget, and we actually should be spending our error budget. Because it turns out if we don't, if we are really like protective of it, bad things might happen. There is a cool story in one of the SRE books that people from SREs from Google wrote. It's about some kind of distributed locking service they had, and it was really stable, like rock solid, and it was so solid that many other services started to rely on it because it was always working. So everyone was using it, and it turns out that when unexpected event happened and this system went down, everything else went down. And it didn't really have to happen because many of those dependencies were like excessive, not really needed, but they were there. So what the team behind the system did is that they started, they've published their SLOs for everyone to see. So they've set the expectations, and then they were causing outages on purpose in production, just so that people do not rely on the service being more reliable than they said it will be. So we should be spending. We shouldn't shy away from spending the error budget because it is for us to spend. It's like there's no purpose. There's no purpose in saving it because it will not carry on to the next period of time. It doesn't work that way. You cannot have a rock solid system for 3 quarters and then give up and have a really bad service level in the last quarter. It doesn't work that way. Yep. So next thing, next pillar of SRE is monitoring. So ways of knowing what's the health of our system. So really reliable monitoring is a key thing if you run any kind of system in production. And there are multiple things that can come out from your monitoring system. One is alerts, when you actually really need a human to do something, which you hopefully shouldn't have too often. Other things are like maybe tickets for your Jira or whatever tracking system for things that for problems that did happen, but they are not critical, they are not so urgent, and it's fine for someone to look at them next week or whenever they have time. And of course, logging is also some kind of monitoring, though its usefulness is for SREs is limited to just the investigative work after things went bad. So it's good to have some logs, but there are other ways of monitoring the health of your system are more important. So at some point things will go wrong. So emergency response is something SREs do. So there's actually no way for an SRE not to be on the on-call duty, because if you are not on call, what incentive do you have for making things reliable? Yeah, well, you are getting paid for it, but that's probably not enough. And we should be trying to get as little need for emergency response as we need, because if we need a human to do something, well, we are screwed because humans have terrible latency. They are not able to fix problems as quickly as software is able to. So if we can avoid such situations, we should. Because, well, having a lot of incidents is having really bad effects on people. not only they get tired, but they get bored of it, and they lose attention. So if you've got a lot of incidents, the quality of your response to them will be lower probably. Another part of emergency response is having run books for on-call engineers. So if you are awakened in the middle of night, it's great to have a written down list of things, of steps to take, instead of just trying to remember what did you do last time that this problem happened. And of course, conducting postmortems after we've fixed the problem or mitigated the problem, because it's not all, the emergency response is more about mitigating the effects the problem has on your system than just fixing, because fixing might need some more time and work by the development team. So after we've mitigated things, we can conduct postmortems, hopefully blame-free if your organization is will let you do that, hopefully. Yeah. So to have a good good quality of the emergency response, we need to train people for that, and there's like a lot of things we can do, like kind of role playing. I think Google called that wheel of misfortune, when they are like showing people graphs, and people are supposed to come up with ideas what they would check next, and what went wrong. So this is really important because it creates a sense of confidence in people. So they will not feel like, they will not be afraid when the phone rings and an alert is fired. And the funny thing here is that if you are having very few incidents, it doesn't have a good effect on people either, because if you've only got an incident once half a year or something, you will not feel confident that you can handle it. So the less incidents if you have very few incidents, people will be afraid of them, because they won't be sure whether they can handle them anymore. So this training should be like periodic. It shouldn't be a one-off event at the beginning when people join the on-call. And one thing that surely doesn't go away when you stop doing like traditional operations and start doing SRE is change management. So because, well, problems are caused by things that change, and we need to manage something. But as I said, the focus in SRE is different. It's not about making sure that we will not break anything when we do the change. It's more about being able to mitigate the bad effects of a change quickly. So it's not about checking the release 20 times before we let some traffic in. It's more about having things like progressive layout rollouts, when we can about being able to spot problems quickly. So maybe canary releases, and about being able to roll back quickly to the known good state after things went wrong. So this is like, those things should be automated as well, because this is toil, like rolling out new versions, and people will get bored, will lose attention, and more problems will happen if they have to do it manually. Okay, so one thing that is critical if we want to scale our system as the demand increases is forecasting the this demand and planning our capacity accordingly. And here we need to remember that our services will not only have organic growth, so like natural adoption, more users registering in. There will be also times of inorganic growth when, I don't know, someone writes a post on Reddit that they really like your service. And guess what? Now there's like twice as many people logging in, registering suddenly as before. So we need to be able to handle those spikes as well. So in order to know how much capacity we have, we should probably be load testing the systems on a regular basis, because, well, it will change over time with the changing application code. And if we are doing this, we should also be probably responsible for provisioning like new resources. And one thing that I've learned on the SRECon conference in Dublin this year is that Google does this kind of exercises on the SRE interviews. So they basically give you a task to design a system, for example, like photo sharing service. So they give you some numbers about how many users they expect, what will be the behaviors of those users. So, for example, how many photos they will put online daily, and then they ask you to come up with hard numbers, how many machines you need, what kind of how much disk space you need. So this they did a workshop on this SRECon conference, and it was really a great experience. And in one of the SRE books, there is an example of such exercise. So if anyone wants to try it, because it's really something interesting to do, you can find it online. And then our capacity is one thing that we have control on. The other thing that we cannot control is the actual demand, so the load on our services. And those are two parts of that say what will be our resource usage. And the first part, which we can control as well, is how efficiently we are using our resources. So SREs can change application code. So if they see the application is doing something really inefficient, they can change it. They don't have to report a ticket to development team and wait 4 sprints before someone picks it up. They can do it themselves. So yeah, how we use our resources is also about costs. So if we use them inefficiently, we generate more costs than needed to the business. So being efficient is a good thing to do. And when we are provisioning our services, we need to take our efficiency into account to reach the levels of performance that we want, the levels of performance the business might expect from us. And a few things, if we want to improve reliability of our services, it turns out there's not many things we can do on a high abstraction level. Basically, what we can do is trade some things for reliability. So we can be trading off money. So we can be throwing more money at the system to buy more redundant resources or bigger servers. But this is not really what I'm thinking about here. Like, redundant resources here will help with the availability of our systems. But we can give up some quality for better reliability. So we can have things like degraded results. We can have circuit breakers that will have some fallback answers when tripped. So we won't get full functionality of our site, but it will still work. It will be up. The business won't be shut down immediately because one thing is failing. And if we do things like retries with maybe exponential backoff and some jitter, maybe it's then we are trading latency time. We are trading time for reliability. So those are all valuable techniques. Just one thing to remember is that every time we do those things, we increase the overall complexity of the application in case of like circuit breakers or the whole system if we are thinking about redundant resources, because well, a RAID array is a more complex thing than a single hard drive, right? Yep. So I think, oh, we still have a few minutes. Cool. So if you have any questions, right, it's time now or later on in outside of the room. But like
from the organizational perspective, you have one SRE team for all the development teams, and you need to know all the services.
Well, in my case, it's not it's not like one or the SRE team for the whole organization, but yeah, I right now I'm the only SRE in the team, which is unlucky, but that's how things are. And the together with the development team, we are responsible for maybe 40 or 50 services. Those are of varying sizes. So there is one huge thing, many things that are like medium size, many small things like some batch scripts and so on. But still, overall, it's like 40 or 50 things.
So you're not you're in the same team as developers. You're not a separate team.
Well, I am a separate team because I don't really. Well, this is something like it's not. You can set it up in different ways, but I am like outside of the development team. I can feed some work into the team, but I need to talk with the product owner to get some tasks into their backlog. But yeah, I'm like not in. I'm rarely joining like some team event, some team meetings, like sprint plannings and so on. Sometimes I do when I have some business to do with them. But yeah, if you we sometimes have like project teams around certain business requirements, so then we can have an SRE working together with the developers as a small team, which we did in the past, like with those performance improvements. But it's not the usual state. Normally, we have this SRE team slightly outside of the development.
What do you automate? Do you automate the performance tests, or do you monitor the logs? Do you automate any tests in production, like health checks? Or, can you give some examples, please?
Yeah, things like health checks and generally things that let us monitor the system better. Also, I'm doing like improvements if I see recurring problems on the happening when I'm on call or other people are on call, because I'm watching the incidents not only on my shift. So then I can take steps, because I know some things will not get a high priority from the product owner, because he's fine with some developer doing it every day in the morning for like half an hour. So I can fix those things as well.
Do you have traditional admins or DevOps still in the organization?
Yeah, in our organization we still have like operations teams. They are responsible for providing us with the servers and infrastructure. So it's not ideal from a SRE point of view. But it's we are using really old infrastructure, So we don't have many applications in the cloud. It's mostly on-prem hosting. So it's there's a dedicated, the client has a dedicated operations team that we have to work with sometimes.
You mentioned about the tools. What kind of tools do you use at your daily work?
Okay, so well, one thing that you should really will be using as SRE is some kind of monitoring system, because building it yourself is most often not the right thing to do. So I'm using New Relic, which gives us a lot of visibility into what's happening in the system. We also have we've got it integrated with PagerDuty for like alerting. We've got elk stack when we need to go through the logs. So I think those are the main tools I use daily.
Do you have DevOps in your organization? Is it something?
Okay, we are running out of time, I think, right? So I'm happy to go with that one, because it's like DevOps is an idea which is like 5 years younger than SRE, and SRE can be seen like kind of DevOps, like a specific implementation of the DevOps. Though I've personally got a problem with DevOps, because I'm not sure whether we talk about the same thing, because what DevOps meant initially, it was about changing the organizational culture. It was not about a job title, right? SRE is a job title. It's also a kind of organizational change, but it is a job. And DevOps as a job, I'm uncomfortable with this term, right? Because it was supposed to meant to break the silos and have people of different areas work together. It was not about one person like doing all the infrastructure code, because it just creates another silo. So we can take it offline if we want to discuss it more. So we can, for us to be sure that we are talking about the same thing. Yeah. So thanks. You should be able to find me around for some time if you want to ask something. There are 2 books by Google SREs that are available for free online. Site Reliability Engineering and the SRE Workbook. Those are really cool resources. And also SRE cons publish the presentations online. So from this year's Europe SRE con, I highly recommend the SRE I Aspire to Be talk. If you're interested in learning some more, it's really maybe not very introduction level, but it's quite simple, and it's a really good one. So thank you.